Hello students, let's do fractions, exercise 3A. Now before that, let's learn about the different types of fractions. So we have the proper fraction. What is a proper fraction? Where the denominator is greater than the numerator. Now if I have to give you an example of this, now denominator is greater, so we'll have the numerator as 2, denominator as 5. So can you see the denominator is greater than the numerator? Another example, I have 9 and I have 16. So here the denominator is greater than the numerator. So this is a proper fraction. Then we have the improper fraction where the denominator is smaller than the numerator. So it's the other way of writing the proper fraction. Now suppose my numerator is 5 and the denominator is smaller than the numerator. This is called an improper fraction. Similarly, just like the other example, we have 16 as the numerator and 9 as the denominator. As you can see, denominator is smaller. So this is an improper fraction. Then we have the decimal fraction. What is a decimal fraction? When the denominator is 10 or a higher power of 10. That is, if I have 3 by 10, this is a decimal fraction. If I have 7 by 100, this is a decimal fraction. If I have 9 by 1000, decimal fraction. If I have 19 by 10,000, this is a decimal fraction. So 10, 100, 1000, 10,000, these are all called higher powers of 10. So whenever the denominator is 10 or a higher power of 10, we call it a decimal fraction. Now, there is another fraction which can be called a decimal fraction. Now, suppose I have 7 by 20. Can you see the denominator is not 10 or a higher power of 10, but we can make it a higher power of 10. How can I make the denominator a higher power of 10? If I multiply 20 by 5, what will I get? 100, isn't it? So now I've got 100. So when I multiply the denominator by 5, I have to multiply the numerator also by 5. So what do I get here? 7 5s are 35. So now what is my fraction? 35 by 100. Now the denominator is 100, so it is a decimal fraction. That means if I have a fraction like this, 7 by 20, where 20 can be converted to a higher power of 10, then 7 by 20 is also called a decimal fraction. Then, what is a vulgar fraction? Any fraction whose denominator is not 10 or a higher power of 10 is called a vulgar fraction. Denominator is other than 10, 100, 1000, etc. Then we have the mixed fraction. What is a mixed fraction? It has a natural number and a proper fraction. That is, I can have a natural number and a proper fraction. Proper fraction is where the denominator is greater than the numerator. So this is called a mixed fraction because it has a natural number. 2 is a natural number and it has a proper fraction 3 by 7. So this is called a mixed fraction. So now that you know the different types of fractions, let's go to the exercise. So here we have exercise 3A on page number 45. Classify each fraction given below as decimal or vulgar fraction, proper or improper fraction, and mixed fraction. So here we have 5 questions given. Look at each one and classify them correctly. Now 3 by 5, denominator is greater than the numerator. And denominator is not 10, 100, 1000 or a higher power of 10. So this can be a proper fraction and a vulgar fraction. Proper fraction because the denominator is greater than the numerator. Vulgar fraction because the denominator is not 10 or a higher power of 10. Question 2, we have 11 by 10. So this is a decimal fraction and an improper fraction. Why decimal? Because it has a denominator which is 10. Why improper? Because the denominator is smaller than the numerator. So this is a decimal fraction and also an improper fraction. Next one, 13 by 20. Now this is a decimal fraction and a proper fraction. How is the decimal fraction? The denominator is not 10 or higher power of 10, it's 20. Now, like I explained earlier, if you have a denominator which can be converted into 10 or a higher power of 10, it's called a decimal fraction. Now, how do we do this? Let's try this and see. Now, if I have 13 by 20, my denominator 20, I can convert it to 100. I can make it 100. How? If I multiply it by 25. 20 into 5 is 100. Now similarly, I have to multiply the numerator also by 5. So this 13 5s are 65. So now what's my fraction? 65 by 100, where the denominator is 100, so it's become a decimal fraction. That's why 13 by 20 is also called a decimal fraction. Now it's called a proper fraction because the denominator is greater than the numerator. The fourth one is 18 by 7. So what fraction is this? This is an improper and vulgar fraction. Why is it an improper? Because the denominator is smaller than the numerator. Why is it a vulgar fraction? Because the denominator is 7. Any fraction which has a denominator which is not 10 or a higher power of 10 is called a vulgar fraction. Next one we have 3, 2 by 9. This is a mixed fraction because it has a natural number 3 and a proper fraction 2 by 9. Question 2. Express the following improper fractions as mixed fractions. So we have 5 questions here and they're all improper fractions. As you can see, the denominator is smaller than the numerator for each question. We're going to convert them to mixed fractions. That means this is now going to become a fraction which has a natural number along with a proper fraction. So how do we do that? We divide 18 by 5. So let's divide the numerator by the denominator. 18 divided by 5. 5 threes are 15 minus 8 minus 5 is 3. So now our quotient, that is 3 here, is going to become the natural number. So that is the natural number. A remainder that is here, 3 is going to become the numerator and our denominator is the same. So that is 5, 3 by 5. Question 2, 7 by 4. So we're going to convert it to a mixed fraction. Divide 7 by 4. 4 ones are 4 minus 7 minus 4 is 3. So our quotient, that is 1, is going to become the natural number. Our remainder is going to become the numerator and our denominator is the same. 1, 3 by 4. Question 3, 25 by 6. So let's divide 25 by 6. 6 fours are 24. Minus 5 minus 4 is 1. So now our quotient, this is our quotient. Quotient is becoming the natural number. Now the remainder is going to become the numerator. Denominator, as I said, is the same. So 4, 1 by 6. Question 4, 38 by 5. Let's divide 38 by 5. 5 sevens are 35. Minus 8 minus 5 is 3, 0. So here the quotient is 7 and that is going to become the natural number. The remainder is 3 and that is going to become our numerator. Denominator is 5. So what is our answer? 7, 3 by 5. Question 5. 22 divided by 5. Let's divide 22 by 5. 5 fours are 20 minus 2. So let's take the quotient and let's make it the natural number 4 and the remainder is 2. That's going to become the numerator and the denominator is the same. So what's our answer? 4, 2 by 5. The following mixed fractions as improper fractions. So we have 5 questions given here and as you can see they're all mixed fractions because they have a natural number and a proper fraction. Now we are going to convert these to improper fractions. So how do we do that? So let's begin with the first one. I'll teach you the first one. So let me write the question 2, 4 by 9. Now we have to multiply the denominator and the natural number. 9 twos are 18 and then add the numerator to it. So 9 twos are 18. 18 plus 4 is 22. So that is the numerator. Denominator is the same as the question. So that is 22 by 9. Let's go to the next one. 7 5 by 13. So let's write that 7 5 by 13. Now multiply the denominator and the natural number 13 into 7. So let's multiply that and see 13 into 7. 7 threes are 21, carry 2. 7 ones are 7, 8, 9. So 91. Then we add 5. We add 5. So that becomes 91 plus 5 is 96. So this is our numerator. 96 is the numerator and denominator is the same. That is 13. Question 3, 3 1 by 4. So that is 3 1 by 4. Let's multiply the denominator and the natural number. 4 threes are 12. Then add this. So 4 threes are 12 plus 1 is 13, which is our numerator. Denominator is the same as the question 4. So what's your answer? 13 by 4. Next one, 2 5 by 48. So again, let's multiply the denominator and the natural number. 48 into 2 is 96. 96 plus 5, let's add it up. 6 plus 5 is 11, carry 1. 9 plus 1 is 10. So what is that? 101. 101 and the denominator is 48. So what is the improper fraction? 101 by 48. Question 5, 12, 7 by 11. So let me write that question. 12, 7 by 11. Let's multiply 11 into 12 first. So let's do that. 11 into 12. 2 ones are 2 and 2 ones are 2. Start the next step. 1 ones are 1, 1 ones are 1. So 2, 3 and 1. 132 is 11 into 12 plus 7. So 132 plus 7. 7 plus 2 is 9, 3 and 1. 139. Now that is our numerator and our denominator is 11. So our improper fraction is 139 by 11. Question 4. Reduce the given fractions to the lowest term. And we have 8 by 18. Now how do we do that? So let me write 8 by 18. Now think of a number that can divide both 8 and 18. Now they are even numbers, that means they are divisible by 2. So let's divide both by 2 and see. Divide 8 by 2 and 18 by 2. And let's see what we get. Okay. 2 into what is 8? 2 4s are 8 and 2 9s are 18. We get 4 by 9. Now look at 4 by 9 and see whether you can still reduce it further. Is there a common factor that can divide both 4 and 9? No, only one can divide both 4 and 9 and you'll get back the same thing. So 4 by 9 is our final answer which has been reduced to the lowest term. So let's go to the second one, 27 by 36. Now again think of a number that can divide both. Now I can think of 3. 3 can divide both. Now think of another number. I can also think of 9. 9 can divide 27 and 36, isn't it? So 3 can divide 27 and 36. 9 also can divide 27 and 36. So let's use the highest common factor, the HCF. HCF means out of these two, which is the highest one? 9 is the highest one. So let's use 9. Let's divide both by 9. You can also divide by 3 and then do another step and get your final answer. So here 9 into what is 27? 9 into 3 is 27 and 9 into 4 is 36. So what is my answer? 3 by 4. Let's go to the next one, 18 by 42. 18 and 42 are both divisible by 2. So they are both divisible by 2 because they are even numbers. They are also divisible by 3 because 18 is already in the tables of 3 and 42. 4 plus 2 is 6. That means it is divisible by 3. Now think of another number that can divide 18 and 42. What about 6? 6 threes are 18 and 6 sevens are 42. So it's divisible by 2, 3 and 6. Now here let's choose the highest common factor, which is 6. So let's divide both by 6. 18 and 42 by 6 and see what we get. So here we have 6, 18 divided by 6, that means 6 threes are 18 and 6 sevens are 42. So what do we have? 3 by 7. So we have reduced 18 by 42 to 3 by 7. Now look at your answer and see whether you can still reduce it further. Okay, you cannot. So this is the lowest term. Question 4, 35 by 75. Now both these numbers are ending in 5. That means they're divisible by 5. Both are divisible by 5. So let's divide the numerator by 5 and the denominator by 5 and see what we are getting. Now 5 into what is 75? 35. 5 sevens are 35 and 5 into what is 75? 15. 7 by 15. That is our final answer. Let's go to the next one. 18 by 45. Let me write it down. 18 by 45. Now, one is an odd number, one is an even number, so it's not divisible by 2. Now, 18 is divisible by 3 and so is 45. 4 plus 5 is 9, so it is divisible by 3. Now, it's also divisible by 9, isn't it? 9 twos are 18 and 9 fives are 45. Now, since there are two numbers, 3 and 9, let's use the bigger one. This is the highest common factor that can divide 18 by 45. So let's divide 18 by 9 and 45 also by 9. Now what do we get here? 9 into what is 18? 9 twos are 18 and 9 into what is 45? 9 fives are 45. So what's our answer? 2 by 5. Okay, we're going to study about a few more types of fractions. First one here is the equivalent fractions. Now what are equivalent fractions? Fractions having the same value. What do we mean by that? Let's take the example of two fractions, 8 by 12 and 14 by 21. Now let's reduce these two fractions to the lowest term. So the first one is 8 by 12. Let's reduce it to the lowest term. Both 8 and 12 are in the tables of 2. They're also in the tables of 4. So both 2 and 4 are the common factors of 8 by 12. Let's use the highest common factor, that is 4. So we're going to divide both by 4. So when we divide both by 4, what do we get? 4 twos are 8 and 4 threes are 12. Isn't it? 4 threes are 12. So 8 by 12, when we reduce it to the lowest term, we got 2 by 3. Now let's try and reduce 14 by 21 also to the lowest term and see what we get. So I have 14 by 21. Now let's reduce this to the lowest term. Think of a number that can divide both 14 and 21. Both these are in the tables of 7, isn't it? So let's divide both by 7. 7 into what is 14? 7 twos are 14 and 7 into what is 21? 7 threes are 21. So 14 by 21, when we reduced it, we got 2 by 3. Now can you see that we have 2 by 3 here and 2 by 3 here? So 8 by 12 can be reduced to 2 by 3 and 14 by 21 also is reduced to 2 by 3. So since both are the same, it means that the value of this fraction and this fraction are the same. Though the fractions, the numbers are different, when you reduce them to the lowest term, they come to the same answer. That means they have the same value. So such fractions which have the same value are called equivalent fractions. Next, we have simple fractions. What are simple fractions? A fraction whose numerator and denominator are whole numbers, but the denominator should not be equal to 0. So these are simple fractions. So let me give you examples. Simple ones, 3 by 5, 7 by 12. These are all simple fractions. Fraction whose numerator and denominator are both whole numbers. The numerator can be 0, but the denominator cannot be 0. So this is also a simple fraction, but I cannot have it the other way. I cannot say 9. Suppose I say 9 by 0. This is not defined. The denominator cannot be a whole number. So what is a simple fraction? It is a fraction whose numerator and denominator are whole numbers like this. 3 by 5, both are whole numbers. 7 by 12, both are whole numbers. 0 by 13, both are whole numbers. But the denominator should not be equal to 0. So here can you see the denominator is equal to 0. So this is not a simple fraction. The next one is a complex fraction. What are complex fractions? A fraction whose numerator or denominator or both contain a fraction. Okay, as examples are, now suppose I write 3 by 4. This is a simple fraction, isn't it? The numerator is a whole number, denominator is a whole number. But if the numerator itself is a fraction, now suppose I say 2 by 3 is the numerator and the denominator is also a fraction, 4 by 5. So something like this, where you have both numerator and denominator as fractions, is called a complex fraction. Or I can even have only the numerator as a fraction and the denominator as a whole number. 2 by 3 by 4, this is also a complex fraction. Or I can have it the reverse way. I can have denominator 4 by 5 and numerator can just be a whole number like this, 9 by 4 by 5. So whenever there are fractions in the numerator or the denominator or both, such a fraction is called complex fraction. So based on that, let's answer a few questions. So here, question 5 says, state true or false. So we've been given two fractions, 30 by 40 and 12 by 16, and we are told that they are equivalent fractions. Now let's see if they are equivalent. That means the value has to be the same. So I'm going to take first 30 by 40. I'm going to reduce it to the lowest term. Both are divisible by 10. So let's divide both by 10. So when you divide by 10, what do we get? 10 into what is 30? 10 threes are 30 and 10 fours are 40. So when we reduced this, we got 3 by 4. Now let's take the other one, 12 by 16. 12 by 16. Now both these numbers are divisible by 2. They are also divisible by 4. So let's take the highest factor, which is 4. So let's divide both by 4. 4 into what is 12? 4 threes are 12. And 4 into what is 16? 4 fours are 16. So what did we get here? 3 by 4. That means this fraction, when you reduced, you got 3 by 4. As you can see, both are equal. So the first fraction, when you reduced, it became 3 by 4. Second fraction, when we reduced, we got 3 by 4 also. So that means 30 by 40 and 12 by 16 are equivalent fractions. That means this statement is true. So let's write that the statement is true. Next one. 10 by 25 and 25 by 10 are equivalent fractions. Now let's find out. 10 by 25. Let's reduce it to the lowest term. Both are in the tables of 5. So let's use 5 to divide them. So 5 into what is 10? 5 twos are 10. And in the denominator, 5 fives are 25. So what did we get? We got 2 by 5. So 10 by 25 has now become 2 by 5 when you reduce it to the lowest term. Let's take the other one, 25 by 10. 25 by 10. Let's divide both by a common factor. And the common factor here is 5. So now let's reduce 5 into what is 25. 5 fives are 25 and 5 twos are 10. So here, this fraction, when we reduce to the lowest term, what did we get? We got 5 by 2. The first fraction, you can see, has become 2 by 5. The second one is 5 by 2. They are not equal to each other. They don't have the same value. So this statement, which says that they are equivalent fractions, is false. This statement is false. So let's write that. The statement is false. Question 3. Here we have 4 fractions and they're all said to be equivalent fractions. Let's find out. 35 by 49 first. So that is 35 by 49. Now 35 and 49 are both in the tables of 7. So we can use 7 to reduce them to the lowest term. So now 7 into what is 35? 7 5s are 35 and 7 into what is 49? 7 7s are 49. So the first one has become 5 by 7. Let's take the next one. 20 by 28. 20 by 28 are both divisible by 2 and they're also divisible by 4. Let's take 4 because that is the highest common factor. So let's divide 4 into what is 20. 4 5s are 20 and 4 7s are 28. So here also we got 5 by 7. Second one is 5 by 7. The third one is 45 by 63. So 45 by 63, both are divisible by which numbers? Both are divisible by 3 and they're also divisible by 9. So 9 is the highest common factor. Let's divide it by 9 and see what we get. 9 5s are 45 and here we have 9 7s are 63. So here also we get 5 by 7. So this is 5 by 7. Let's take the last one, 100 by 140. So now this one, both are divisible by 2, they are divisible by 5, they are divisible by 10. So now before we continue, what we can do is we can cancel off 1 0 from top and 1 0 from down. So what do we have here? 10 by 14. Now these two numbers, 10 by 14, are divisible by only 2. So we're going to divide both by 2 and see what we get. 2 into 5 is 10 and here 2 into 7 is 14. So here also we get the fraction 5 by 7. So as you can see, all these fractions have been reduced to 5 by 7. That means though they are of different numbers, their value is the same. So what does this statement say? That all these fractions are equivalent fractions. That means this statement is true. So let's write that down. The statement is true. Next one, distinguish each of the fractions given below as a simple fraction or a complex fraction. I hope you remember what simple fractions and complex fractions are. Now the first one, 0 by 8. Okay, both the numerator and the denominator have to be whole numbers and the denominator cannot be a 0. So the first one is a simple fraction. Second one, we have 3 by 8. Numerator and denominator are whole numbers and denominator is not equal to 0. So this is also a simple fraction. Third one, 5 by 7. 5 and 7 are whole numbers. 7, the denominator is not 0. That means this is a simple fraction. Now fourth one, in the numerator we have a mixed fraction. So if you have a fraction in the numerator or the denominator or both numerator and denominator, then it is called a complex fraction. Question 5, 6 by 2, 2 by 5. So numerator we have 6 and denominator we have a mixed number 2, 2 by 5. So this is a complex fraction. Question 6. We have 3 1 by 3 in the numerator and in the denominator we have 7 2 by 7. So this is also a complex fraction. Question 7. 5 2 by 9 is the numerator and denominator is 5. So since we have a mixed fraction here, this is a complex fraction. Question 8. 8 by 0. The denominator is 0. So this is neither a simple fraction nor a complex fraction. So this is neither. So children, with this we come to the end of this exercise. Thank you children.